Today, I'm sitting down with Eric, the #1 contributor to AutoGen. For those who don't know, AutoGen is a framework from Microsoft. It is a pioneer in building multi-agent AI systems. It is also incredibly popular with over 50,000 stars on GitHub. He's here to share his secret on agent design, multi-agent workflows, prompt engineering, and so much more. Eric, you are the #1 contributor of AutoGen. Do you mind start by sharing us with what is AutoGen?
Right. So AutoGen is an open source agent framework, and it started in Microsoft in 2023. Started as a research project, and it evolved a lot. It iterated through many different versions. So right now we're in version 0.74, and it's relatively stable at this point. And AutoGen was inspired partly by the idea that what can we do if we have multiple agents instead of a single agent? Can we increase the capability of a single agent by using orchestration patterns to enhance and to augment, the capability of a single agent? So in the beginning, we tried many different things. One of the idea was sticking out, which is you can put different agents in the same chat. So it sounds very, abstract. So and concretely, what's happening is you have multiple agents and they just append to a single message log. And each time the agent absorbs the same message log that all the other agents can see it, and then produce the next result.
Could you give us a very concrete example? Let's say maybe I want to do data analysis. How would this messenger, how would this chat room look like?
Right, yeah. So here, one example is when you have a data analyst task, and you have maybe a data scientist agent that's responsible for writing data science, data processing code. And you have data visualization agent that is responsible for visualization. And you have, let's say, search agent that is responsible for obtaining the raw data or raw information. And then you also have a group chat manager that's responsible for routing the subtext between those agents. So typically it works by you have an input task from the user, and the group chat manager will decide ad hoc what is the sequence of the sub-agent to be invoked. So this is the group chat orchestration pattern. It has become really popular, and I think all of the major agent frameworks supports it.
Awesome. So what is the history of AutoGen? Is the group chat emerged somewhere in the middle? And I know there's a lot of drama instead of AutoGen. Do you mind share a bit more on that side?
Well, I think all successful open source project has a lot of interesting personalities. I think that, I started off in AutoGen not as the main leader of this project, but over the time I become the leader of the project. I think one of the lessons I learned from this experience is people might have different views of how an open source project should evolve, and that is okay. And I can see that the people who used to be part of AutoGen project, now they have started successful startups, right? They go on to other interesting research projects. So I think that it's really good that the open source project is able to kind of evolve and diversify our landscape. I think I really appreciate that, my opportunity to be able to work on this project and eventually maturing it into the state it is.
So did you remember when you made the first PR to AutoGen?
Yeah. It was a long time ago. So AutoGen used to be part of a different repo, and so we were making PR to that one. And I think in the beginning we were trying to figure out what is the right communication architecture between the agents. And one of the idea was I was having this idea of having a event-based message stream. So all the agents, instead of calling each other's method, we have shared event stream where all the agents writes to that stream, and so they all subscribe to the stream. And I think in the beginning this architecture was a little bit involved, so that it wasn't easily it was not easy for developers to use in the beginning. So for the fast iteration and also to get things out of the door quickly, so we decided to use a different type of messaging architecture. But in the 0.4 version, we decided to bring this into the core, we call it AutoGen core. So in the AutoGen core module, it is basically an event bus with different public publish and subscribe mechanism, so that agent can publish to a topic and subscribe to a topic, and there can be multiple topics in this event stream.
So after so many years of developing AutoGen, what do you think is the secret towards building best agents?
Well, that's a good question. So a couple of things. I need to first of all say, as a platform developer, as a developer making this stuff, I'm not the person making the best agent. I'm helping or trying to offer a kind of a good and easy to use abstraction so that application developer can build on top of us and create the best agent, right? But because of being a platform, so we have the opportunity to, observe different kind of applications. And generally speaking, the successful agents are not really, of course, you need to have the best model, but not so much about the model because everybody have access to the same models, right?
Yeah.
It's usually the tools, the thing that is outside the model that determines how successful that agent is. So
you just provide some example?
Yes, totally. So one example is in one of the research project, we try to beat the GAIA benchmark, the GAIA, for
Could you just for the audience, explain what is a benchmark?
Right. GAIA benchmark is a set of very hard tasks to test ability of general purpose AI assistant. So this is a research project. We will have something here later. And the idea is, well, how do we create an agent that can, work on general purpose tasks, not just say only for data scientists, but only through agent issue, but for any kind of task. So for that project, what we found is, model definitely help. With weaker model, you get bad performance. But ultimately, what brings the score up to the number one on the benchmark is the ability to very effectively browse the web and very effectively download files from the web and then make sense of those files.
Do you remember what are the example tasks? Just go through an example end-to-end task in GAIA benchmark.
Right. Yes, of course. First of all, I just want to say the most of the work is not me. I'm just paraphrasing what the contribution of the researcher work on this GAIA benchmark work. So first of all, one example is in the GAIA benchmark that you have to, let's say, so there is a website, you give a link to this website as a part of the task. And in the website has an image. And in the image, there is a piece of code. It's screenshot of the code. And so you need to extract the code from the image and run it. And then the code will produce a link to another file in another website. And then from that website, then you have to find out a piece of content in that website. And based on that piece of content in that website, you need to produce an answer. So
is it kind of like solving an maze?
It's kind of like that. So what really happens is you need to be able to run the code and very effectively, right? You need to be able to browse the web and jumping through different hubs you have to do. The website is not always intuitive to use. And you also need to be able to, read and extract content from a local file. So there's a lot of tools that's involved, and those tools may not necessarily made with AI, right? So they could just be like regular Python code, but they need to be very well written, and they need to produce text output that the model can consume very easy. So I would have to say one example. So one of the researchers who built this tool separately create another open source project called Markdown, and that Markdown is like the number one starred repo in Microsoft, I think shortly after VS Code. And it's crazy. The whole thing is really transferring any kind of file content into Markdown. And so that tool turns out to be super useful for agent because models are trained with text content, right?
So you provide the Markdown as a tool for the agents, and it boosts your performance on the benchmark of GAIA.
Yeah, basically, yeah. So it turns out the tools are super important.
Yeah, could you explain more on what is Markdown? How is it different from the naive tool use of parsing file? Why it makes such a difference?
So a couple of I think we need to consider when we create tools for agents is like different from tools, like in a general software sense. Like when you think about a piece of software, there's a contract for what's the input look like. It's a structure, events or message or some kind of type data structure. And it produce similarly some kind of typed output data structure, right? And the input could be parameterized with nested objects. So you can imagine the input output of a typical software system is very complex. But if you try to build a tool for the model, you don't want to give directly that interface to the model. Yes, you could. Model does support structured output and input and does support structured function call. But if you start to nest, to have a huge nesting structure inside the function argument, you're going to confuse the model. So I think the key is you really want to simplify this. So you want to make sure the arguments are as simple as possible.
Could you provide example of nested action?
Yeah. So from the AutoGen users, I've seen people asking this question. Like one time I see somebody having this issue with the agent using the tool. That's one of the effective. So one of the argument is it's a web search, right? So it's basically try to wrap around a simple wrapper around the search API. But the search API does support a nested dictionary sort of structure so that you can put in your preferences on, what's your locale, what's your preference on language, how many of it, that kind of thing. And you just give that to the model. And that dictionary structure is very complex. So the model was given a huge, like a schema, like the very nested structure schema. The model gets confused more often, and so the result wasn't very good. So my suggestion to that user was like, okay, like you really need that many parameters, just like simplify this into a single string, or at most a couple of other parameters with basic types like integers or string. So that makes it much easier for the model to understand. And in most cases, for your application, you don't really need that complex of choices for a parameter. If you encounter that, you should think about maybe you should need a separate agent so that each agent can be responsible for that specialized subset of the tasks.
What are the different dimensions do you think separates a good tool design versus a bad one?
One thing I already talked about, the interface of the tool needs to be simple for the model. And the other thing is the output of the tool. Don't output garbage. Try to reduce as much noise as possible from the tool itself. And then I think the other thing is you could also mix AI with the tool as well. A tool could be an agent in itself, right? So I think one of the most popular multi-agent patterns is not really group chat, actually. Is actually just making agents a tool. And you have a hierarchical list of agents. And they all organize in a kind of a recursive callbacks.
Yeah, so they still communicate to natural language. It's natural language in and out, but instead of having maybe passively or maybe actively reading the group chat, they kind of passively receive the tasks of a message of tasks and work on that task.
Yeah. One of the challenge with that kind of approach is context sharing. So oftentimes the model needs a lot more than just a command you send it to it. So let's say you have a hierarchical, the hierarchical orchestration that with tools is agents. And when agent issue a tool call with the command, it just say, oh, please go to this website and download this file, right? It may seem simple, but the agent might need more information than that, right? Because what is the website? What if I go to that website and it doesn't have a login? What should I do? What should I put in my login? You go to that website and it has like 3 different choices and it all seems like they can arrive as a file. And if the initial user provided context has those information and your model does not provide it to the sub-agent, how would the sub-agent know about it?
Yeah.
So the context sharing is actually critical. So when you design a multi-agent system, you can't just easily you can't just simply chain them together with input and output between the agent. You also have to have them share some kind of common context that they all have access to. They all can post to. So the easiest way is just to make sure all the messages are available to all the agents, and then you have the problem solved. Of course, you get a context length.
But does that reduce to single agents again? If they share the
not exactly, because it turns out that the persona does work. So if you do personifying each agent with a special built system prompt, it gives an agent more focus. But I agree. I mean, when a model becomes better and better, this effect seems to become not as important.
Yeah. How do you draw the boundary between agents if they share similar context?
I think you always want to start with an agent that is, try to start with a small number of agents. Like, don't assume that you need multi-agent just because it is more capable. Multi-agent system has its downside. It costs a lot more tokens, and it's also slower because now you, instead of a one single IAM tool, it goes to multiple of them, and you have to be routed, right? So I think start from simple architecture and start it small. And even if you already have a sub agent, so a lot of people's users' reason for building a multi-agent system is because they have a lot of existing agent. They don't want to rebuild the agent. They want to use the existing agent. I think in those cases, it's not that you have to have all of the agent in the same chat session. What you might need to do is just to route to the special agent and go with that agent and don't change, because like it's more cost effective. Yeah.
So how many of the tools or agents should one single agent communicate with? Let's say like agents I want to do data analysis. Should I give them 10, 20? What's the threshold where just things get out of control? When is the sweet spot?
So the OpenAI does recommend 20, I think, or maybe less. I can't remember the exact numbers. So yeah, so I would say go with less than that number is a good idea. Yeah, I think maybe we can talk about MCP. So one of the problem with MCP server, it doesn't really seem to consider that as a constraint. So MSR has a report on MCP server, and it's called MCP Interviewer. I can encourage you guys to check it out. It's really good in terms of how do you really think about building the right tool interface for your agent, and how all the MCP server right now kind of not quite optimized.
So for the audience not familiar with MCP, what is MCP and how is it different from tool use?
Right, good question. So they are the same, but they're not. So MCP server, or MCP, the full name is Model Context Protocol. So the idea is, how do you provide data to the model? And the protocol is essentially a set of rules that you should follow to provide the data. And the MCP basically said there is a unified way of doing it. How do you provide the data? Instead of every application invent a new way to do it. So make it like, you can think of it this way, like before MCP, everybody needs to build their own tool. Or if they need to use somebody else's tool, they have to wrap it. They have to build some kind of adapter. With MCP, then, if everybody start publishing their tool with the same interface with the model, how they provide data to the model, then you don't need to write the adapter. Or maybe that's too much of a simplification, as I said earlier, because instead of end-to-end how the model and the tool works, and you build with a full transparency of your stack, now you have a black box in your stack. You might not understand and it might change it. So when using MCP, you have to keep in mind that like you need to actually understand what is the format that they provide to the model, so that you actually don't get surprised that using MCP actually degrade your performance. So that is common issue. And MCP, again, even with this issue, I think it's a net improvement in our ecosystem, because now all of a sudden we can have a network effect, or we can have an ecosystem. Before that, it was more like everybody doing their own thing. So I think it's still a good thing, but the protocol itself still have to evolve.
What's your view? I think you mentioned before, start with single agents, but there is actually some debates. I think Anthropic has one post on how to building multi-agents, and ironically, Cognition just made another post on don't build multi-agents, I think just one day after Anthropic's post. So there is some debates inside of industry whether we should go for multi-agents or just single agents is sufficient. What's your take? Which side are you on?
My side is every side. Everything, there's no side really. So my take is that we're still very early in this AI era. So I wouldn't say that there is a rule, or there is a particular kind of paradigm that we already say, oh, this is it, and we don't have to know anymore, learn anymore. It's evolved really quickly. So for example, like the group chat patterns, it's a multi-agent pattern. It was useful in 2023 to have 4 do better. I don't think we need to have that for GPT-5.
Why? Could you elaborate why the group chat is only for GPT-4, not GPT-5?
I think it's I wouldn't say is the number of useful scenarios will be a lot less for group chat with GPT-5. Because one of the issues the group chat try to address is the agent tends to get distracted. can confuse if it has a long instruction, complicated rules in the instructions, and it provides with too much context or have many tools associated with it. And now with stronger models, some of these concerns are going away. So one of the things that we do need to keep reevaluating our architectural decisions very frequently and see whether it still makes sense with the new model. So with the GPT-5, for most of the cases, if you are working on a data scientist task, I don't think you should use sub-agents. I think you should just use a single agent in GPT-5 and equip it with the best kind of tools that you can really make, and that should give you a better results compared to use 5 GPT-5 models, each with different kind of specialty. What multi-agent does become useful, I believe, is when the tasks do become much more complex.
When do you think is the point when someone face challenging difficulty, they should start thinking about multi-agent?
Right. I think, put it this way, like if your single agent start to perform worse because of the task has become more complex, and you can try to start splitting the task into sub-agents through the agent tool or as a group chat and see how well the performance improves. And I think it's very empirical. I wouldn't say there is a clear-cut rule that you can just follow to decide. Right. And I think the other thing to think about is if you have specially purpose-built models, especially models that have been fine-tuned to work on a very special purpose task, then it also makes sense to use multi-agent because you actually ended up have lower latency when the model is executing on the special task.
Yeah, not that we're discussing specialized task here. There is actually another debate on whether we should use agent at all or using a specialized workflow that tailor to these tasks. So when do you think we should consider agents? When do you think we should consider workflow or a combination of them?
Yeah, that's a really good question. So I put it this way, like one thing, what are we building? If we're building a general purpose assistant, then I think it's an agent. It is you cannot anticipate what the users might ask you to do next. And you might not anticipate what you might encounter when you execute a task. Then it's an agent or a multi-agent system would be suitable for this type of task or scenario.
Did you provide example?
So like the kind of GAIA task I discussed earlier, right? And a ChatGPT will be an example, right? And a Claude Code or Codex CLI, Gemini CLI, Copilot, those have a diverse set of possible inputs. And there are many different execution paths that can happen. So those, I believe, needs to be built with an agent system. And on the other hand, if you have let's say a business process that you know exactly what scenario you're going to encounter. Let's say you have a workflow for returning an order from an e-commerce website, right? There is a specific requirements you need to follow when you return an order. Let's say you need to have the right address, you need to have the right order number, you need to verify the order has been purchased, right? It's not fake order. And you need to verify their account name and so on. So there's a set of procedures that you have to follow. In those cases, it's best to use more deterministic approach. So a workflow is better in this case because then you can encode your business processes as part of it, and you're making sure the result when the workflow does terminate, your task is complete. So it gives a lot more. It's naturally matches how like most of its functions. They're not trying to build a chatbot; they're trying to build what they're building like already. So also a lot of the business processes are not customer facing; they're running in the backend, and they all have very special purpose. So in vast majority of these are workflow. And I believe that have a really good workflow system and how you design the system is critical.
And what's your view towards prompt engineering or context engineering, which is a buzzword these days? I think a few years ago, people are all talking about how do I do this prompt? Let me share my prompt with you and so on. But nowadays, the prompt engineering seems a little bit outdated, and people have a new buzzword of context engineering. So, what are the difference, and how do you think are they important in the context of building agent design?
I don't know what is context engineering. I think it's there are many people try to think about this in a different angle. I would say, like maybe in the beginning, prompt engineering. Okay, this is my interpretation of what it is. So I think in the beginning, prompt engineering was really about the actual words that goes into the prompt and the way you say it. Like you have to, for example, add do not do something, or like the way you format the prompt seems to be very important. So that was my impression of prompt engineering, is people who are very familiar with how the model works in a very intuitive sense, so they can write good prompts, and the people just share this prompt. So, oh, this prompt works with this model. So that's prompt engineering. But that is completely going away because the model is getting really good, and there are automated prompt tuning, and you just kind of really mutating the prompt and just massive do the search and see which prompt works better. So that area is going away. What's still very important is what you put in the prompt, in a sense of whether the relevant signal is available to the agent when the agent is performing some task. I think that is maybe what people are referring to as context engineering, because as in like the exact form, like exact words appear to convey the signal may not be as important, but the signal itself needs to be there. Like the agent needs to know about the name of the function before it can run it, right? Or the agent needs to know about what is, let's say the function takes the query language, the DSL. The agent needs to understand the DSL. And so you need to load some kind of DSL rules or maybe DSL is a very complicated example, but like if you have a function and the function takes certain domains of inputs, you need at least to put like what are the possible inputs or what kind of format you need to follow when you use the function. So in a different example is, when agents repeatedly running into the same, let's say same error when it executes some tasks, it would be a good idea if the agent eventually figured out, or if you have a way to help agent mitigate, you should have that as part of the prompt. So this, I think maybe they call it context engineering, because the exact way you write that, it doesn't matter, but you need to have that in the prompt. So that's what my view is. And I think that, yes, it is extremely important to make sure you can constantly improve the agent by having this context available, and how you curate these contexts should be part of the application.
Talking about evaluation logging, what do you think is the best practice in terms of monitoring agent behavior, debugging agents' issues, and so on?
Guys, evaluation is a huge topic. And I think that one of the things is we need to understand what is the task that the agent is trying to achieve. So again, most of the time, you're not building a chatbot, a general purpose chatbot try to do everything. So the evaluation should be very purposeful. So like, what is the actual state your agent needs to move to, and then see if that state has been satisfied. So like, for example, if your onboarding agent, is it successfully onboarding the customer? Or if you have a tree agent, is it successfully resolving the tickets? Like, I think those things are the metrics.
Yeah. So then metrics need to be end to end. But if they don't satisfy the metrics, do we debug in agents? How should we figure out what's wrong? Tune the prompt, should I change the tools, and so on?
Yeah. So if you go look at the agent framework, they have some support called telemetry or observability. So you can do that as well. You don't necessarily need to use agent framework just to use telemetry. So when you run your agent, when you deploy your agent, technically, I wouldn't say you run your agent in a debugging setting in a development environment. But as you deploy your agent and people start using it, you should think about collecting the traces like the agent emits. So it's like, in a more simpler way to say is, you should capture the logs of the agent's actions, so that like later on you can kind of visualize, you can aggregate those logs to give you a better picture of like how well your agent is performing, so that you can have aggregate statistics showing like what is the end result that you want the agent to do, and how often does the agent achieve that result. And then based on that, then you can go back and see, okay, maybe there's a certain step that the agent always gets stuck in, or maybe there is a certain step that is always associated with a specific kind of tool, and maybe you should think about how to optimize that tool. So I think going from starting, you have an initial version of agent to a better version of agent, you need to go through this process of constantly iterating and observing the agent.
Let's talk about no-code solution, because there are a lot of people that are non-technical, potentially mostly those inside of business. They see a very tedious process. They want to automate that with agents, but they are not that tech savvy. So we also have a lot of no-code, low-code solutions even for AutoGen, we have AutoGen Studio. What is your take on these approaches? Not have people start with low-code solutions, or should they also try to learn the basics of agents themselves?
So this is one of the things that I think most of the local no-code solutions are not agent. They're more like workflows. And the good ones, they make it really explicit what is executions in their UI. So if they do a very good job, then it should be immediately obvious, even to someone who doesn't know how to write code, what actions are being taken at every steps, right? So most of these software, they have a very easy to use interface, allow you to drag and drop and connect different actions together. And each of the actions is very clear. For example, like if the agent says something, and then you should start maybe send the emails, or you should put a role in a database, you should like trigger another agent. So like there's a way for you to construct this business logic with these actions. And I think those are super useful. Because of that, it's not really, I would say it's not really an agent per se. It's more of a chain of actions. And to be honest, I think the value of most of these software is not that it has AI. It's that it has a huge number of connectors.
Oh yeah.
And those connectors help you to, quickly whip up some kind of solution without having to write the code. And in most cases, the people who use the softwares to build stuff also know how to write code. It's just that makes their life a lot easier if they don't have to.
Got you. What's your view on small local models? Because people, especially for open source models, because a lot of the companies want to use model, but they also are concerned about data and information security. So they have to use smaller. ChatGPT just released an open source version of GPT. We also have a lot of these small llama Quen models. They are not as capable as the latest frontier models. So what is the best practice to design agents or workflow using these smaller models?
Yeah, I think I have to say I don't have a lot of experience with local small models because, frankly speaking, I don't think they are that useful even now. I mean, they are pretty useful for special tasks, and if you really have designed it well, prompt it well, and you making sure it only focus on that specialized task, I believe it can get a very good result. But again, if you look at the numbers and GPT-4 or GPT 4.1 mini or nano models are extremely cheap to use, and they're latency wise, most likely they're going to be faster.
Besides the designing better tool space and the better context management, there's another dimension on fine-tuning the models. What's your take on fine-tuning? Should people start with that? Should people try agent design first? What kind of tasks are more suitable for fine-tuning?
Right, fine-tuning is a big topic. I'm not an expert in fine-tuning. I'm just talking about what I have learned. So I believe fine-tuning, based on my understanding, is not to. In many cases, people kind of relate this with distillation. They say, oh, I have a small model. I want to have same capability as a large model. That's never going to be the case. And what's really happening is you have maybe certain behavior pattern that you observe in the large model. You can replicate that in the small model, but doesn't mean that it will always work with a small model. What really happened is actually fine tune a medium-sized model, not a small model. Rather, like what you take is you get a GPT-5 mini or GPT 4.1 mini, and you fine tune it with some domain specific tasks. And it might be that your company has a certain set of rules that are different from everyone else. Of course, most companies are like that. And you have a specific set of APIs that you need to understand how to best use them. But those knowledge about those APIs are I would say, probably, even if it's part of the training data of this large model, probably all lost or have a very low resolution of it. So in those cases, what you're really doing is to sharpen the model so that it becomes really good at that specific scenario. And because you're also deploying a smaller model, you get this much better latency. But the cost is still going to be higher because the hosting of the customized model is going to be more than using a general purpose one.
So what is next? What is next for AutoGen? What is next for this agent design? How do innovation is the most biggest topic in next, let's say, 3 years that people all should learn about?
I think you need to be updated with the latest development, and you constantly reevaluate your architecture decisions And the blog post that's written a year ago may not be relevant. You'll have to reevaluate that and you have to run it yourself. I think right now is a very exciting time because I can't give you the answer what to do. So, and even the expert in the field only has maximum 3 years of experience, right? So it's really easy to catch up and things are changing fast. So the new paradigms are being invented. It's a really good time to get in and to learn about what's the latest and start to, prototype, start to try new things because like, trust me, I said many things may not be correct after a couple of months. So yeah, keep trying.
Eric, thank you so much
Yeah.
for coming to the podcast.
My pleasure. It's great talking to you.